Hi everyone, it's Mrs Jennison here and I'm an Associate Director for Outwood Grange Academies Trust. Welcome to today's lesson. In today's lesson we are looking at metal extraction. Our challenge is to be able to describe the methods of metal extraction. The aspire is to be able to explain why they are used for different metals. Now metals are typically extracted from their ores. Now the term ore means a naturally occurring solid material from which a metal or valuable mineral can be extracted profitably. Now we quarry to obtain ores from the surface of our earth or from the earth's crust. So here is an example of a quarry. It's essentially where we dig up sections of land to obtain those materials. Now some ores we have in a high abundance, so we have quite a high amount of iron ores, and others are limited in their supply. So for example, copper is quite a limited resource. On the screen you can see copper ore. Now the copper is obtained from the green chemical inside of that ore, which is actually copper oxide. And we find that most of our ores are obtained from oxides of the metals. Now that means that to use the copper we need to remove the oxygen from the copper oxide. Now the process of removal of oxygen is called reduction. Now I'd like you to use what we've covered so far to define the term ore and to say where we find ores and how we obtain these. The term ore means a rock containing enough metal ore for it to be economical to extract from this source. Now we find ores in the Earth's crust and quarries are used to obtain these ores. Now when we are extracting metals, the reactivity of that metal will determine which method we use to extract it. Now on the screen is the reactivity series of metals, from the least reactive up to the most reactive potassium. So the higher the metal is in this list, the more reactive it is. Now we can use this to help us know how that metal is extracted. On the screen is a link to a video which has a really nice way to remember these reactivity series.
This, my friend, is a song about metals, like the kind you find in your kettles. Promotes the least reactive, cause oxygen's quite attractive to all the metals in the reactivity series.
Break it down now.
First up, potassium, sodium and calcium, magnesium and aluminium. Just for comparison, carbon's had to jam with them. It's It's not really a metal. Zinc, iron, tin and lead, hydrogen and copper, lead, silver, gold and platinum. So my friend, just to summarize and bid you a goodbye, just remember this song and learn to sing along. I guarantee that you will pass the exam.
Break it down now.
First up, potassium, sodium and calcium, yeah, magnesium and aluminium. Just for comparison, carbon's there to jam with them. It's not really a metal. Zinc, iron, tin and lead, hydrogen and copper, lead, silver, gold and platinum. One more time now. First up, potassium, sodium and calcium, yeah, magnesium and aluminium. Just for comparison, carbon's there to jam with them. It's not really a metal. Zinc, iron, tin and lead, hydrogen and copper, lead, silver, gold and platinum.
Now, it's not really a metal referenced in the song. Carbon is added to the reactivity series to show which metals can be extracted using carbon. Hydrogen is also added to the reactivity series to show which metals will react with acid, and it's also used to predict the products of electrolysis reactions. For the metals at the bottom of the reactivity series, they are found pure in the crust, which is why we have used silver and gold for thousands of years. It's because there is no extraction required. For the remaining metals that are less reactive than carbon, we can use carbon to extract them from their oxide. We essentially carry out the process of reduction, so we react the metal, oxide, with carbon, and it removes the oxygen. So the example on the screen is copper oxide, when reacted with carbon and heated, forms copper and carbon dioxide. But for the metals above carbon, this can't happen because they are more reactive than carbon. Therefore, carbon cannot be used for reduction. So instead, there are some alternative methods we can use. We can use electrolysis of a molten compound, or we can use a multi-step extraction process where we carry out a series of chemical reactions in which to obtain the metal. Now, neither of these methods are sustainable. Electrolysis has a very high energy demand, especially because you have to electrolyse the molten compound, and when these are ionic compounds, they have incredibly high melting points. So you've got to heat it to a high temperature to perform the electrolysis, and then use electricity in which to carry out electrolysis. So that's a huge energy requirement. The reduction with carbon has got a lower energy requirement, but produces carbon dioxide as a byproduct, which you may remember from an earlier topic is linked to global warming. Both of these methods are also only best used when you have a high grade ore, which is ores which have a high amount of the metal to extract. If you are using a low grade ore, you would not obtain enough metal to offset the cost of the process, and that is not economical. So using what we have covered so far, which methods would you use to extract the 4 metals seen on the screen from their oxides? If you have a little bit of extra time, it'd be really good practice to complete some word equations for any that you would extract by reduction with carbon. Okay, so for aluminium, you would use electrolysis or a multi-step extraction method. Copper, you would use reduction with carbon and the word equations on the screen. Gold, you wouldn't need a method as it's found pure in the crust. Zinc, again you would use reduction with carbon and the word equation is on the screen. So, iron ore is extracted by reduction with carbon. What environmental impacts will the extraction of iron from its ore have? Okay, so you could have both of the ones on the screen at the moment. The first issue is that you're producing carbon dioxide, which is linked to global warming, causes global warming. The second issues are in the quarrying itself, the mining. They cause two types of pollution: visual pollution, which is the correct way of saying it doesn't look very nice, and noise pollution. So people aren't going to want to live near those quarries. Also, there is some impact on habitats of the animals that would normally live in that area, which is not an advantage at all to those animals, as they will either get confused and continue trying to live there, or they'll have to move out of that area. Now, it's time to have a go at some exam questions. So the first ones are on the screen. Which of those metals is found in the earth as the metal itself? Then, iron is found in the earth as iron oxide. Iron oxide is reduced to produce carbon. And they'd like you to have a go at balancing the equation seen on the screen. Once you've done that, they'd like you to name the element used to reduce iron oxide. Next question, what is meant by the term reduction? Now, if we look at the mark scheme, if we look at the first question, 3 of the metals were very clearly quite reactive. You can tell because their names ends in ium, which means that it's gold that was found as the metal itself. For the balancing of the equation, if you look at your oxygens first, okay, you've got 3 oxygens on one side and 2 on the other. So the number that you are aiming for has to be, those two need to be a factor of. So if you aim for 6 oxygens, you'd have a 2 in front of the Fe2O3 and a 3 in front of the CO2. Then that means you've got 4 ions on one side, so you have to have a 4 in front of the ion on the reactant, on the product, sorry, and a 3 in front of the carbon. The element used to reduce iron oxide was carbon. What is meant by reduction in terms of oxygen, it is the loss of oxygen. Now for the next section, we've got some higher tier only content. If you are on the verge of moving on to higher, or you are unsure of what tier you will sit, it could be worth you watching this because this may be something that you really understand. Now, these reactions can be classified as redox reactions. During reactions, metals will lose electrons and become ions, and some metal ions will gain electrons and become metals. What we do is we use half equations to illustrate what is happening. So, oxidation is the loss of electrons and reduction is the gain of electrons. We remember this using Leo, lose electrons, oxidise, the lion goes grr, gain electrons, reduce. Now, if we look at the equation here, I want you to look for which metal is becoming an ion and therefore is losing electrons. And if it's losing electrons, it's being oxidised. And which metal is gaining electrons and is therefore being reduced. If you can, it could be worth having a go at then writing 2 half equations to show what has happened to the zinc and the copper, and then you can write an overall ionic equation for the reaction. Now the species which has been oxidised is the zinc, as it has lost electrons because it formed an ion, which is why it is now in a compound with the sulfate ion. The species that has been reduced is copper because it has gained electrons, and you can see that because it was attached to the sulfate ion and it isn't anymore. Now, using the half equations, you could see that the zinc has formed Zn2+ and 2 electrons. The copper has gone from being copper 2+ and it's gained 2 electrons to form copper. Now the overall ionic equation would be Zn plus Cu2+ goes to Zn2+ plus Cu. Now let's have a go at an exam question. Iron is a metal that has many uses. Iron is extracted from iron ore. Part of the process involves reduction of the ore with carbon monoxide. Iron ore contains iron oxide, Fe2O3. Write a balanced equation for the reaction of iron oxide with carbon monoxide. Then, can you explain why this reaction is a redox reaction? So the equation would be Fe2O3 plus 3 carbon monoxide would form 2 ions plus 3 carbon dioxide. You got one reaction for the correct formula of the reactants, one mark for the correct formula of the products, and a mark for the correct balancing. Now, the iron is losing oxygen, which is reduction, and the carbon gains oxygen, which is oxidation, which is why it can be classed as a redox reaction. That's everything for me in this lesson, and I will see you in the next one.